Hi, welcome back to the IntroStat lecture. And for this video, we're going to cover a new topic. It's a hypothesis testing for the population mean. If let's do a little bit of refresh here, since it's a long break here. Okay, so before that, we did a hypothesis testing for the population proportions, right? So the population proportion is we are testing the certain proportion equal to certain numbers. So we'll have like H0 is like proportions basically is percent, right? So it's a P equal to the P0. Then the verse three different that non-alternative hypothesis. So we have HA, P is not equal to P0, and the P is greater than P0, and the P is less than P0. So right, like the typical example we used many times in the class is what is the percent of the UD student population if come from a single child families, right? So that's the P equal to certain number we think. So we also talk about this is what is the lecture. I think this is the lecture 3 or lecture 4. I think this is lecture 4, right? And then we also talk about the population proportion for the two population. So we will say it's P1 equal to P2. So that means the two population, their proportion are equal, or you can write this is a P1 minus P2 equal to 0. Then the same way, we have three alternative hypotheses here. So we will have like a P1 not equal to P2, or we have a P1 minus greater than P2, or we have a P1 less than P2, right? So other way you can write this will be P1 minus P2 not equal to 0, or this one you will say P1 minus P2 greater than 0, and this one you will P1 minus P2 less than 0. So we covered this topic in our previous lecture. Number 5 here. So we start a new lectures today. So we're going to talk about the hypothesis testing instead of the proportion. We are testing the mean, or use a little bit easier way. We say it's the population average. So instead of using mean, I think everybody can understand the population averages here. All right. So just like a proportion for the population average, we will have two kinds of the test. All right. So this is we said the one population. We have one population mean. That is what is the lecture number 7 we're going to cover today. So the same way, we're going to have two population means. So it's very similar like to what we did. So this will be in the lecture number 8 and lecture number, I think it's lecture number 8. All right. So this will be the two new topics we're going to talk about. So today we're going to start lecture number 7. So we're going to talk about one population mean here. All right. So okay. So this is the introduction. So let's go into our lecture notes here. Okay. So let's go. All right, so from the introductions, we know we are talking about the one population mean test here. Okay, so for the hypothesis here, let me using the, okay, so this color will be good. So hypothesis, like we said, the mean is mu. We test one population, right? So we say mean is equal to mu zero. That means specific numbers we want to test. So like we said, average, like this city's family income will be 85,000. Then we said mu zero equal to 85,000 here. So just like always, the we have three different alternative hypotheses, right? So everybody should be very familiar with, right? So we have mu is not equal to mu zero. We have mu greater than mu zero, or we have mu less than mu zero here. All right. So now for the test statistic, like always, I don't really require you to remember, but in here we have a little bit of difference in the population proportion. So for the population proportion, we just use the test statistics, but for the use the z-test, right? But in the testing of the population mean, we have two kinds of tests. We have z-test and we have t-tests here. So when to choose z-test and when to choose t-test. So it all depends on the population sigma is known. If you know the population sigma or they give to you, then you can use the z-test. How about if the population sigma is unknown, then I'm going to use the z and t-test. See here. So basically, okay, so the test statistic, let's try to write it. So if I use the z-test, right? So this will be x bar, so that will be my sample average, minus mu zero is the number I try to test. Then here is the sigma over square roots of the n's here, right? So the x bar, what is the x bar? This is the sample averages, right? So when you take a sample, then you average it. And what is n? Is the sample size. Good. All right. Then the see here, because the sigma is given or sigma is known here, right? So that's why I divide by the sigmas here. All right, so the same things here, when the population sigma is not given, so now I will need to use the t-test here. Okay, so for the t-test, the test statistic is very simple. So will be x bar minus mu zero. Now here will be s over square root of the n. So the only differences is this s here, right? Because the population sigma is unknown, so the x bar still is a sample size, the sample average, n still is a sample size. What is the s? This is the standard deviation for the sample. So remember in the in the lecture number 6, we have the formula for the standard deviation for the sample. We said is this, right? So it's the square roots of the summation xi minus x bar square, then divided by what? N minus 1, right? So this is what is the S equal to. And like I said, it's good for reference. You write it down, and then later, we will be able to, you don't need to remember the formula. You can just use the calculator. All right, so now let's focus on the z-test first, okay? So the z-test is telling us now the next things here we need to know is how do I find the critical value? If you remember, when we did lecture 4 and 5, I'm going to give you the critical. So the previously, the critical value is given, right? I give you a table, you can find the critical value. But now, since we finished the lecture number 6, we know how to use the normal table to find the critical value. So now in here, you don't have to have the alpha value, is always, the fix on the table, right? Because in the table I give you, I said the alpha value could be 0.1, 0.05, or 0.01, right? So, but now in here, you can have any alpha values here. Okay, so how do we use the critical values here? So for any given alpha value, okay, so for any given alpha value, so how do I find the critical value? It depends on if you have one tail or two tail. Remember that, right? So in here, if it's not equal, this is the what? This is two tails, right? And the other one, this is one tail, and this is one tail, right? Okay, so now let's take a look. How do I find? So for the any given alpha values here. All right, so now let's see here. So if this is only for the one tail, okay, so I'm going to show you by using the calculator. So let's say here, so the given alpha is equal to 0.04. From the previous, I never give you the 0.04, right? Okay, so now let's go to the TI calculator, see how do I get this, the critical values here. All right, so now let's go ahead and go to the TI-84 calculator. Okay, here's my TI calculators here. All right, so now for this example, it's alpha equal to the 0.04. Okay, so for alpha equal to 0.04, let me turn the calculator on here. Okay, so alpha 04, if it's one tail. Okay, so if it's one tail, okay, so let's do this. We do a second, all right, bars, all right. So now we are going to use the inverse norm, okay? So remember the areas here is always we put it to the left here, all right? So the alpha equal to the 0.04. So the area will be 1 minus alpha, 0.04. Okay, then you do dot, 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 dot. So what is you have? You have 1.75. Okay, so this is 1.75. Now let's go back to the lecture notes here and see how do we put on the notes so you won't forget. Okay. Okay. So we did one tail. It's a 1 pointer. So the code we use. Okay, the things we use here will be, if you remember, we said a second, right? So the first key is the second vars, right? Be careful, see here, second vars. Then you use the inverse norm. Okay, so then you use the, so this is what is used. So this is inverse norm. Okay, then your area, so input your area. So the area input, the area you will say is 1 minus your alpha values here. Okay, so this is 1 minus 0.04. Area is 1 minus 0.04. then you will get the values. Here is like we say it's 1.75, right? Okay, so here is one thing we need to be careful. Okay, so 1.75. So if this is one tails, right? So if your non-hypothesis is right tail, okay, so then here is my critical value. So the critical value, I would say Z star. Okay, so then the Z stars here is 1.75. Okay, so here write this way. So you will say if yes, your alternative hypothesis is mu greater than mu 0, then the Z star. Okay, so Z star, that's your critical value, is what you find 1.75. Okay, so now how about if you use so if your alternative hypothesis here, this is this way, right? So if you have another one tail, if you do the smallness here, right, so here then your Z value, your critical value will be negative 1.75 because it's on the left hand side here. So that is why you need to be very careful. So this is depend on your alternative hypothesis, right? So your alternative hypothesis, this one's mu is less than mu 0. Okay, all right. So now this is the first part. Then the second part here. So if you have a two-tail test, okay, so how do you do it? So let me move this p-value down a little bit, right? Okay, so here, okay, so if you have a two-tail test, how do you do it? So the first few steps is the same. So you first do a second, then you hit the key called var, then you hit the inverse norm. Okay, now in here, your area will be, areas here will be 1 minus the 0.04 divided by 2, right? Because now you have a two tail, so it's divided by 2. So now let's go to the calculator to take a look. What is my critical values here? All right, so let's go to the calculator now. Okay, so you should see my calculator now. Okay, so let's do again. So let's say the second vars, then you go to inverse norm, right? Then now instead of 1 minus 0.04, you say 1 minus 0.04 divided by 2. See here. All right, so it's 1.08, 1 minus 0.02, so it's 0.98. So you do the same thing. Now, what do you have here? You will get a 2.05. Okay, so now let's go back to my lecture notes and see how is this 2.05 looks like. Okay, so let's go to the lecture notes. All right, so we just got the z equal to 2.05. So what's that means here? All right, so so now the two tail, right? So this will be two tail. So the two tails, our HA will be mu is not equal to mu zeros, right? So two tails here, so that means I have two tails. Because a while ago we used the calculator, it's tell me it's 2.05. So here is 2.05. And here is, okay, so you put this is the 2.05. then this one is negative 2.05. Okay, so you compare your test statistic to both, right? So then I know the z star will be 2.05 or negative 2.05, right? So it depends on where is your test statistic. But anyway, so the one in those shaded areas rejected regions here. Okay, so now the next thing here is the p-value. P-value is a little bit easier because we can use the function to do that. So this is the sample mean for the z-test, right? So let's take a look which function I'm going to use here. All right, so let me go to the calculator again. Okay, here is my calculator. Okay, so in order to get the p-value, so let's do this. So I'm going to use the stat here, STAT, stat, and I'm going to use the test. And so because this is a so popular test, so the first we use the first test, the z-test. All right, so you use the z-test. You can choose you have a data or you have a stat. That means if you have a summary statistics or they just give you the raw data here. So let's take a look. So the stat, that means they give you the summary statistics here. So let's take a look at stats here. So basically your input here, because this is sigma is known, right? So you input what value you try to compare, what is the sigma value you try to compare, what is the average, what is your sample size, okay? And then for the next example, we're going to take a look how to use the data here, all right? So that is the, so let's try again, is a stat, then we go to test, right? Stat, go to test, then it's a z-test here. All right, then you want to choose stats in the t-test, in the z-test, unless they give you the raw data here. All right, so that is about the calculator. So let's go to the lecture notes and let's try to write it down here. All right. All right, so a while ago we see, we see the calculator. So how to use the TI calculator? Which key we use here? All right, so first one we use the stat. Okay, now under the stat, we want to choose the test, right? Now under the test, we choose the number one, z-test. All right. Now under the z-test, we choose we want to input the statistics. All right. So now after you do that, just like we did the population, they will give you the test statistics, they will give you the p-value. Okay. So the p-value will be given. So the p-value will be given after you run the program. Correct? Okay, so now I am going to go down to see the example we have and I'm going to show you how to use the TI calculators, right? So this is, be careful, this is how to find the critical values here. So for the Z test, so afterward, my second video going to talk about the t-tests here. Okay, so now let's take a look at this example, example number one. So let's say the average college student goes through 500 disposable cups in a year. To raise environmental awareness, a student group at a large university volunteered to help count how many cups were used by students on their campus. A random sample of the 50 students' result, okay, and they used the mean 476 cup with a sigma 42 cups at alpha equal to 0.1. Is this sufficient evidence to conclude the mean difference from the 500? Okay, so let's highlight the key information. All right. So they say they think they go through 500 disposable cup. So they want to do a test. So they take a random sample of the 50 students. And then from this one, they give you a result. It's 476 cup. And here they say, oh, in here with sigma equal to 42 cups. And now the alpha value is equal to the 0.1. So this is less in evidence is different from the 500s. So all this are the key informations, right, for this problems here. So now let's say the hypothesis we want to do is mu is equal to what? 500. So the average is 500 cups. Let's say different. So I say mu is not equal to 500 here. All right. So in order to do the test statistic, because since the sigma, like in here, I highlighted in green, since the sigma is given, so use z-test here. Okay, so now let's get some information about this z-test. So what is this one? So n is 50, sample size is 50, and with mean 476. What is that? That is the mean from the sample, right? So x bar is 476. Okay, so now that put those information into the calculator, get our test statistic. And then they also want to find the critical region or p-values here. All right, so let's go to our calculators. So here, see, how do we input this data and how do we get the information here? All right, here is my calculator. So here, okay, here's my calculator. So now let's go ahead. So remember, right? Okay, so let's quit. So remember, okay, so let's review one more time. Use stat. Then I'm using test, right? Then under the test, I'm using stat. Okay, so mu zero is what the value I want to compare to. So here's 500. The sigma is given, so I put this is 42. And the x bars here is a sample average. I put is 476. What is the sample size? Sample size is 50. And because of my alternative hypothesis is not equal, so I choose this one. Not equal. So now I do a calculation. Okay. So now here is what here is what we have here, right? So z is equal to the negative 4.04. This is my test statistics, right? Then p is equal to 5.333 e to the negative 5. So in here we need to be very careful about this negative 5. What's that means here, right? So x bar equal to 476 and n equal to 50. All right, since we are in the computer, got in the calculator, so let's take a look at my critical values here. So the alpha value the problem give me is 0.1, right? So the alpha value point give me is 1. Okay, so let's try to see if we can find the critical value because this is a two-side test here, right? 0.1. Okay, so let's see. So it's a second bars. Remember that? Inverse norm. All right. Then is 1 minus pointer 1 minus 0.1. Okay, so it's 1 minus 0.1 divided by 2, right? Because 2 tail. All right, so maybe, okay, so here, all right, so then let's see what I have here. So it's 1.645. Okay, so 1.645. All right, so now let's go back to the lecture note, see how do we apply this information here. All right, so let's go ahead and go to the lecture notes. All right, a while ago we got it. Test statistic is negative 4.04. All right, so the p-values here, be careful here, p-value is we have is 5.33 to the e to the negative 5. Some people might wonder, what the heck is this, right? All right, so e to the negative 5. This is a scientific notation. All right, so basically that means here's my value, 5.33, right, p-value. That means you move the decimal point 5 positions. So here's my decimal point, right? So it's 1, 2, 3, 4, 5. So you move your decimal to here, and then you fill in. So this is 0 point. All this little one, you put in a 0 there. Okay, so basically this is telling you your p-value is 0.00005. Okay, 533 if you want 0.00533. So be very careful. This is what is this e to the negative 5 means here. All right, so a while ago we also find the critical value. All right, so let's take a look at what that critical values mean. Because this is a two-tail test, right? So like we said, so my critical value given is 1.645. So that means here's my critical value is 1.645. Remember what happened to the left hand? You will have a negative 1.645. Okay, so now, okay, so this is my Z, that is the critical value, Z star, right? So critical value, Z star could be 1.645 or negative 1.645. Okay, so now we have all this information, then we can make decisions here, all right? Okay. And now in here for this ones here, our decisions here will be, you can either compare the p-value. So you'll say p-value is equal to the 0.00005. It's less than my alpha value, right? So 0.1. So this is my alpha values, right? So this is alpha value. So we know if a p-value less than alpha value, we will reject H0. That means data provide significant evidence to support, student use the different than the 500 cups here. All right, so now let's do a second comparison. It's a test statistic. The Z is equal to negative 4.04. So my test statistics here, get a good colors here, all right? So my test statistics going to be negative 4.04. So negative 4.04 is here, right? So it's a negative 4.04. So it's inside the shaded areas here, right? So then you will set here test statistics. It's inside. What is this shaded area we call? It's the rejection region. All right. So what is the conclusion? So we will reject H0. All right. So this is the first part by using the z-test. Okay, so that's it. All right, so I'm going to stop this video. I don't want this video be too long, and so I'm going to stop here. But the basic things is here is you need to learn is like the three hypotheses, right? So that when the population sigma is given or known, we use z-test here. So we just finished the first one. So my second part of this lecture will be next video when we said sigma is unknown. How do I use the t-test here? And here is the outline for your calculators. All right, that's it. Okay, so and make sure to review this one very carefully so you won't get lost for the next one when we talk about the t-test. All right. Okay, so looking forward to talk to you again soon. Okay, bye bye.